Well, this is a little video for my freshman orientation, and unfortunately I can't be here today. Actually, unfortunate for you, fortunate for me, I'm in a different country and hopefully underwater right now. But in the meantime, I'm making this little video, and I thought, well, what can I do to introduce science class? And one of the things that unites areas of science is energy. If you're talking about our place in the universe, or you're talking about the place of an electron in an atom, or you're talking about metabolism in the human body, it's all about energy. So I'm going to show you some different energy resources today, and my assistant, Mr. Mrzinski, is going to help us out. Hope you enjoy. So when we talk about energy, energy is the ability to cause a change, and we think about different forms of energy. It's hard to explain what that all means. But take this tennis ball. If I throw the tennis ball, hey, Mr. Murrow. The tennis ball had energy. All right, another form of energy that we use all the time is electricity. And everybody knows, we plug the cord into the wall, and all we got to do is turn it on. And you can see the plasma that's formed when the electrons are jumping across it. Mr. Mrzinski.
Yeah.
Why don't you hold on to that for me for a while?
Absolutely.
Another form of energy that we can look at is called thermal energy or heat energy. And what I have here is called a heat lamp. And so it's plugged into the wall. There's electricity flowing through these little coils here, and these coils are getting really, really hot. And you should be able to see that orange color there. And one thing that's neat about heat energy is this form of radiant energy. Radiant energy travels in the form of waves, so they travel outward, and you can actually aim this, so I can aim it at Mr. Mrzinski. Hey, Mr. Mrzinski. Are you warm enough there?
Oh yes, this feels amazing. Sweating so bad. Whew. It's like a hot sunny day here.
All right, now we're going to talk about a little sound energy. Sound is a form of energy. Another form of energy we have, well, not really a different form. We say there's potential energy. Potential energy is stored energy, and it's stored in an object's position. Now I have a shot put here. If I pick up the shot put, it took a little effort on my part to pick it up. And you say, well, where did that effort go? Where did that energy that I used to pick it up go? Well, it's stored in the object. Okay, it's stored in its position because the shot put wants to go back to the ground. When I set that shot put on the table here, it wants to go back to the ground. Oh, gosh, oh. So when we looked at the shot put, when I lifted it up, the shot put was above the ground. It wanted to go back to the ground, and we had some energy stored in it. Well, right now, Mr. Mrzinski is at the top of this ramp. Since he's above part of the ramp, he's got some potential energy. So if we give him a little push, Another way we can store energy is by deforming something, by stretching or squeezing or bending it. So on this little device we have some rubber bands. And if I pull these rubber bands back and lock them in place, again, it took me some effort to pull that back. You know, actually in science terms we call that work. I applied a force through a distance. So I did some work. I put some energy into it. You say, well, what can that energy do? Well, if I put this little ball in place, hey, Mr. Mrozynski, catch. So what I have here is an air gun, right? What I can do with this, you got a piece of PVC and there's a chamber down here and there's a valve, and the valve right now is closed. And I have a little air compressor here, and with the air compressor I can squeeze more air inside. Now I'm going to squeeze a bunch of air into my pipe. It's just a small air compressor, so it takes a little while. All right, I'm at about 36 PSI. That PSI stands for pounds per square inch. That's roughly about the same pressure that you put in your car tire. And you say, well, how is this energy? Well, I took air, which made up little molecules, and the molecules are normally spaced apart from each other, and I squeezed a whole bunch of them together in here. So they're closer together in here than they are out here. And if you give them a chance, it's a little bit like a spring. If you have it compressed, if you give it a chance, it wants to uncompress. So if I open this valve, these particles want to get apart from each other. Now, by itself, you know, that's just going to make a little whoosh, and that's no fun. So what can we do with it? Let me get a paper towel. So, what I have here is basically a giant spitball. And if I put this in the end, it's good and soggy right now. And put that in here. Let's see who we can get. Hey, Mr. Mrozynski.
Oh, keepers, man, Mr. Rupp, why are you doing that again? Come on.
Another way that we find energy is actually stored in the chemicals and materials that make up our world. And so what I have here is a simple silvery gray metal called zinc. And I have some of that zinc already in the bottom of this flask. You know, we can just add a couple pieces more in here. No big deal. There should be enough in there for what I need to do. And what I have here is a clear, colorless liquid called hydrochloric acid. Hydrochloric acid is a solution in water, but there is some acid in this. And my assistant here, Mr. Mrozynski, is going to add that acid quickly to the flask. And as soon as the acid is in, take the funnel away. Okay? Lift it up a bit. All right, and a chemical reaction is taking place, and if you look in the bottom here, you can see a lot of bubbling going on, and I'll tell you, the jar is already starting to get warm, and the most obvious change we can see is with those bubbles, we're collecting the bubbles in our balloon up here. Now, the gas that's forming is called hydrogen. And again, the topic is energy. So the energy is these chemicals that I mixed together had energy in the bonds that hold the materials together. And some of that energy is being released right now in the form of heat. And there's a change in the materials. You know, we didn't have a gas before. We had a liquid and a solid. But now we're forming a gas. And we got to let that go just for a little bit. And then we're going to tie off our balloon. So, Mr. Mrozynski, how do you like your balloon?
Oh, thank you very much. This is amazing. I love it. Thank you.
You know the best part about a hydrogen-filled balloon, though?
No, what?
There's still energy in it.
I can see that. Cool.
Watch this. Hold on.
Oh, wow. This is awesome. Yes. Oh!
Run.
So, Mr. Mrzinski, do you think we showed them a few things about energy today?
I believe we did, but you know what? I thought of one more example of energy transfer.
Oh, yeah? What's that? Well, energy. It's the ability to cause a change. I guess we showed that today. Have a good day.
Okay, now you are.